ಗುಡ್ ಮಾರ್ನಿಂಗ್ ಎಲ್ರಿಗೂ. ಲಾಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ ನಾವು ಸೆಮಿಕಂಡಕ್ಟರ್ ಪ್ರಾಪರ್ಟೀಸನ್ನು ನೋಡಿದ್ವಿ. ಈ ಕ್ಲಾಸಲ್ಲಿ ಪ್ರಾಬ್ಲಮ್ಸ್ ಆನ್ ಟ್ರಾನ್ಸಿಸ್ಟರ್ ನೋಡೋಣ. ಅಂದರೆ ಆಲ್ಫಾ ಬೀಟಾ ಗಾಮಾ ರಿಲೇಷನ್ ಕೂಡ ನೋಡೋಣ. ಅದರಲ್ಲಿ ಆಲ್ಫಾ ಮತ್ತು ಬೀಟಾ ರಿಲೇಷನ್ ಈಸ್ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಸಿ, ದಿಸ್ ಈಸ್ ಅ ಟ್ರಾನ್ಸಿಸ್ಟರ್ ಸ್ಟ್ರಕ್ಚರ್. This is actually a common emitter transistor structure because here emitter is common to both base and collector. See, for both base and collector emitter is common. So I am telling you the trick here. There is only one trick you have to remember. That is, in a common emitter base and collector side of setup, collector side has to be the right side has to be considered as output. This is considered as output and this is considered as input. Remember, in the common emitter type of setup, the right side or the collector side is considered as output and the input side is usually a base. Correct? Yes. In a common base type of setup, collector is output and emitter is input. What is output? Collector is output and emitter is input. Okay, so this is common base kind of setup and this is common emitter kind of setup. Okay, this is the transistor. Since I told you this is a common emitter type of a transistor, on the right side we are having a collector and so it is output side, and on the left side we are having a base, so this is input side. Okay, here input current is considered as IE and or IB or IBE. What? Input current may be considered as IE or IBE or IB. Okay, input resistance is considered as RI or RB. RI or RB. Input voltage is considered as what? VI or VB or VBB or VBE. Okay, come on once again. Here input current is considered as current is considered as I input or I base. Input resistance is considered as RB, that is base resistance, or RI, that is input resistance, and input voltage is considered as VI, input voltage, VB, base voltage, VBB, base voltage, or VBE, input voltage. Similarly, on the left side we consider resistance as RI, RO, output resistance, RC, collector resistance, VCC, collector voltage, VCE or V output. Similarly, current we consider it as IO, output voltage, or IC, that is collector current. Okay, so basically right side is our output and collector is connected to the output, and input is our base, and that is on the left side we are having. Okay, so output current, since I see here, I have to consider current gain as beta is equal to output current divided by input current. Output is related with collector, so it is IC, and input is related with the base, so it will be IB. Suppose it is common base type of a base of a circuit, then it will be formula will be IC by IE. Okay, that is considered as alpha. Okay, next, voltage gain is output voltage VO divided by input voltage VI. Output voltage means by applying Ohm's law we know that voltage is I into R. So here also I into R, but I means what in output? That will be collector current. R means what? That will be RC, collector current. Okay, in the similar way, base side will be, input side will be base IB, and this will be IB, but IC by IB is what? IC by IB is beta, so formula becomes AV is equal to IC by IB is beta, so it becomes beta into RC by RB. Okay, yes, two formulas we have to consider here. One is AV, another one is current gain. Okay, one more time I'm repeating, the right side should be considered as output, that is in output resistance is IC or IO, RC or RO, output current is IC or IO, and output voltage is VCC or VCE or VO, and input voltage is VBE, VI or VBB. Input current is IB or IE. Input resistance is RI or RB. Okay. And one more formula, very important formula we are having here. See, IE is equal to IB by IC, because in the entire circuit in the previous class I have told you that emitter is highly doped and most of the charges will emit from input, from emitter. So emitter current is always equal to base current plus collector current. You can remember it with a trick, that is emitter produces current, sum of the current moving in base and collector. Okay. Alpha relation is IC by IE. This usually happens in common base collector, common base kind of a transistor, that is IC by IE. And IC by IB, beta happens to be in common emitter kind of a circuit. Mainly they will ask problems on this. Okay, they have a lot of love to respect towards this formula. They will ask definitely formula from problem from depending upon this formula. Okay, yes, this is basically common emitter kind of a problem, IC by IB. Okay, alpha is equal to IC by IE and beta is equal to IC by IB. Okay, you can see, pause the video or take the screenshot, you will get the answer. Okay, thank you. Next we move on to some typical problems that have been asked in CET exams. See, first of all, I am having CET 1998 problem. The relation between they have given beta, the current factor, and the value parameter alpha. See, relation between alpha and beta is alpha is equal to beta divided by 1 plus beta. Okay, what is the answer? Beta here is 99 divided by 1 plus 99. So what happens? Alpha is equal to 99 by 100, so that will be around 0.99. okay, what is the relation between alpha and beta? Alpha is equal to beta divided by 1 plus beta. Sir, what is alpha and beta? See, we have seen here alpha is IC by IE and beta is IC by IB. This is related with emitter, common emitter transistor, and this is alpha is equal to IC by IE is related with common base kind of a transistor. Okay, this is alpha and beta relation. Alpha is equal to beta by 1 plus beta. CET 2003 they have asked a question, in case of constants alpha and beta of a transistor, alpha is equal to beta, beta is less than 1, alpha is greater than 1, alpha beta is equal to 1, fourth one is beta greater than 1 or alpha is less than 1. Which one is the answer? See, even though alpha and beta are connected with a different formula here, alpha is equal to beta divided by 1 plus beta. In case of constants alpha and beta, if they are considered to be a constant, then alpha is equal to beta will be a correct answer. So here formula is different. This formula appears only when we are connecting it in a particular transistor. For example, if we consider it as a common base or common emitter type of a transistor, then we will get this relation. Otherwise, if we consider only alpha and beta current factors, that is IC by IB and IC by IE, then alpha and beta are usually related with the formula alpha is equal to beta. Next we move on to the next formula. Don't get confused here. In COMEDK 2005, in common base configuration, delta IC, common base transistor means I have told you base comes here, collector here, emitter here. Okay, yes, delta IC and delta IB has given the value of alpha. Alpha means what? Alpha means IC by IE, isn't it? Alpha means what? Alpha means IC by IE. Okay, for that see here, alpha is what? Alpha is IC by IE. IC by IE. I have to calculate that. For that, prior to that, they have given IC and IB. I have to calculate IE. We know that emitter current is equal to collector current plus base current. So 2.4 microampere plus 2.4 microampere I have to add, and I will get it as 4.8 microampere. Substitute this 4.8 microampere here. This will be 4.8 microampere. IC value will be 2.4 microampere, and we will get the value. And and we will get the value that will be around that will be around 0. That will be around 0.96. That will be around 0.96. That is because here what happens, collector current will be in the range. Here collector current, see here we are having um collector current is of the range of 2. This formula is actually 2.4 into 10 to the power of minus 3 ampere. Then you will get this relation. In Comet Kit 2005 they had a grace marks for this problem because they have mentioned it as 2.4 microampere. If you solve 2.4 microampere, you will get the answer as 1 by 2. That is not in the option. But if you substitute 2.4 microampere, then add it to 2.4 into 10 to the power of minus 3 ampere, that is 2.4 milliampere. Then add it to 2.4 microampere, or convert this into 10 to the power of minus 3, or else convert this into 10 to the power of minus 6, and using this formula you will get the answer. Okay, use this formula. This is for this is for if I consider both as microampere, and if you consider it as 10 to the minus 3, 10 to the power of minus 6, add this and you will get the answer. And on dividing using this formula, you will end up with answer somewhere around 0.96. Okay, CET 2007. Next question. In reverse bias diode, when applied value for voltage is 1 volt, applied value of voltage is 1 volt, and current found to change, current is 0.5 microampere. That means what? By using Ohm's law, V is equal to IR, I have to calculate what is R. R is equal to V by I. V is 1 volt and this will be 0.5 microampere. Answer will be 2 into 10 to the power of 6. If I take this upside, and microampere becomes 10 to the power of 6 omega. So resistance is what? 2 into 10 to the power of 6 omega. Okay, see, please see the problem perfectly. First of all, you have to solve this problem with utmost accuracy, because the problem was actually wrong. Okay, the grace marks was given in 2005. Okay, yes, we move on to next problem. Identify the diode in which forward bias. See, forward bias means what? Forward bias means current should move from P to N, and P's voltage should be greater than N's voltage. If it is 9, it has to be 5. If it is minus 4, it has to be minus 2. Okay, voltage should be maximum. Voltage should be maximum on the P side, and it should be minimum on the next side. Okay, identify the forward bias. See, only B. Say, first of all, we will see here grounded, that means 0 volt, here minus 5 volt. This is definitely forward bias, because this voltage 0 is maximum when compared to minus 5. In the same way, 5 to 0, this is also forward bias, because 5 is maximum when compared to 0. Here current is moving from this direction to this direction. Definitely minus 2 is larger when compared to minus 7 volt on the scale, so it is also forward bias. But 2 volt to 3 volt is not forward bias, because this is smaller. This is smaller when compared to 3. So the option is what? Option A, B, C is perfect. Okay, yes. See, please check once again. Okay, you use the previously solved formulas, and can you solve this problem? This is for homework. Okay, please solve and comment the answer. We will give assignment related to this, and please solve digital electronics problems by yourself. Please draw the diagram and study all AND gate, OR gate, NOR gate, etc. Okay, I am not going to solve all those gates because they are very simple, and we move on to the next topics. Okay, very important topics. So please solve digital electronics by yourself, and if you have any doubt, I am going to give one assignment on digital electronics. If you have any doubt, please give me some photos in Facebook problem solving groups. Okay, yes, thank you. I will solve them. Okay, yes, please solve all the assignments given in your WhatsApp or in Google Drive. Okay, thank you.